Okay, so we're going to solve systems of equations today, having to change two of the equations. Two of the equations instead of one today. Remember our goal for eliminating? Our goal for eliminating is to cancel out something. And to cancel out something, it means they have to be the opposite. That's what our goal is. What the best strategy that I can tell you is cancel out that first letter. That will help you the most. I mean, there's quicker methods, and some of you could grab the quicker methods, but I just want us all to be on the same page, and I think that cancel the first variable out first. So what you're going to do is multiply both equations by something to cancel one another out. So what can I turn 2 into and 3 into that can cancel it out? 6, and good job. What I would do, it's kind of hard to explain this, but my strategy, think of the common denominator. What is a common denominator between 2 and 3? What is it? Uh-oh. What's a common denominator between 2 and 3? 6 is the common denominator. So I want to turn 2 into a 6 and 3 into a 6. Except they need to be opposite. So I want to turn 2 into negative 6 and 3 into positive 6. So what do I need to multiply this by to turn 2 into negative 6? Negative 3. What do I need to multiply the bottom by to get to positive 6? 2. Okay. Now distribute to everything. That means everything. Uh-oh. I'm turning a plus a negative because I'm distributing a negative. Okay? Eli.
Both equations?
No. Well, I wouldn't for this one, no. The only time I turn it to plus a negative, you can, Eli, you like doing plus a negative. The only time I do it is when I distribute a negative.
You get the same answer.
Yep, you sure will. 6x plus negative 3 times 3 is positive 9 equals negative 3 times 0 is 0. Distribute the bottom. 2 times 3, 6x, minus 2 times 2, 4y, is 2 times 5, 10. Now see what happened there? Now I can cancel my x's out. That was my purpose. Negative 6 plus 6 is nothing. 9 minus 4 is 5y. 0 plus 10 is 10. Y is 2. Uh-oh. Now that part, where the heck does that go? You got 4 equations you can turn it into. You could do the original, the second original, the new one, or the second new one. Put it into any one of them. They all stink. It's never fun doing it. I'm going to turn it, where should I bring it? I'm going to choose the top one, the first one. So this is going to go right there. So 2x minus 3 times 2 is 0. 2x minus 6 is 0. Add 6. 2x is 6. X is 3. So these two lines intersect at the point 3, 2. So my strategy here, my goal was to turn my 2 into a negative 6, my 3 into a positive 6. So I times through by negative 3 on the top equation. That's what I got here. It looks like a mess. I times by positive 2 in the bottom equation. That's what I got there. Combined them, plugged it. It looks crazy. All 2y is 1, and 4x minus 2y is 10. So what should I turn them into? Right?
Well, you could just multiply the top one with
Yep, because your goal is I want to cancel out. Well, if this is positive 4, I want to turn this top one into negative 4. So I'm going to times everything here by a negative 2. This is fun. Okay, now distribute. So distribute negative 2 times 2 is negative 4x plus negative 2 times 3, negative 6y equals negative 2 times 1, negative 2. The bottom equation I'm just going to write under it. It's easiest to do your math that way. So that's just me writing that bottom equation down. Since I have a plus and negative on the top, I'm going to go ahead and put plus and negative on the bottom. Just so they're the same, because I have to combine. Negative 4 plus 4 is nothing. Negative 6 plus negative 2 is negative 8y. Negative 2 plus 10 is negative 8. Just kidding, positive 8. Y is negative 1. Uh-oh, now where the heck does that go? Into any of the equations. You choose. Whichever one you think is not ugly. And even if you think they're all ugly, you still choose one. So I'm going to put it on the top one because there's no negatives. So now I get 2x plus, let me expand this for you. 2x plus 3 times 1 equals 1. Two x plus 3 is 1. I put it right here. Right there is where I put it. Oh, that's negative 1. Yep, my bad. So now I'm going to plus 3. So 2x equals 4. X is 2. So these two lines intersect at the point 2, negative 1. Okay, one last thing with systems. Sometimes you come across these special kind of systems. Special means when all the variables disappear and you get a false statement like 1 equals 3, or a true statement like 0 equals 0. Okay, you're going to get something that looks like that. False means no solution. True means it's an infinite amount, or all real numbers, we said before. So no solution. A system is a point of intersection. It's two lines. So if I have no solution, how many times does it intersect? Never. So never means that they're parallel lines. So no solution means parallel lines. It means they will never ever intersect in your whole entire life. In their whole entire life. Okay? So if you get a no solution, it means they're parallel. If you get a true statement, a true means all real numbers or infinite. It means, let me draw a different color. If I said infinite, it means they're always intersecting. Well, if they're always intersecting, it just means that they are the same line. Okay? So you have two special solutions. No solution meaning they're parallel, they never intersect. And an infinite solution, which means all real numbers is where they intersect, which means they're the same line. Okay, there's never a point where they don't intersect. Okay, so parallel means no solution. Infinite means they're the same line. Alright? So those are the examples on that one.